Hello class, some of you apparently need help with these regression questions, so let me run through them right now. Here you have a question that asks you to run 3 regressions. This is regression 1, just price to book value on return to equity. This is one variable for y, one variable for x. Here, the same variable for y, different variable for x, and finally this variable for y and 2 variables for x, right? So let us run those 3 regressions. This is the data I have. How am I going to run the 3 regressions? I'm going to click here on data, then on data analysis, and then here I'm going to select regression, okay? Here I have to input the y range and the x range. So y is the variable you're trying to explain, and x is either the variable or the variables that you are using to explain this. Now, I've noticed that I usually try to just do it this way, give the whole column for here. So for the first regression, we're just doing price to book value ratio on return to equity. So it's going to be y is the A column and x is the B column. I try to do it like this, and usually there's going to be some sort of error for me. Sometimes it's going to say there's a problem. Here, like this, for instance, it says input range contains non-numeric data. What does that mean? Well, it's because here this is text, and so it's not happy. What I need to tell it is just click this labels, right? So labels just means that the first row are labels. Okay, then I try this again, and actually it still doesn't work. It gives me this alert. And I found that the way to solve this is just to actually select the data that we want. So I go in the A column and I select exactly the number of rows that I want. Like this. Here for B, you can do the same thing. You can go and select it like that, or you can just write it. You can just say that this is $B, $1 to $B, $72, because you know they actually have the same shape, it's just in the other column. For the output range, because we're going to do 3 of them, I'm pretty happy just stacking them one after the other. So let's put one of them here, let's say, and then we'll put another one lower and another one lower. Okay, so this is the first one. This is my first regression. Okay, so now let's do the second one. Again, we go to data, data analysis, regression. Here we're still using the A column as the Y, but now we want the C column as the X. The easiest for me here is just to change these letters right here. Don't forget to change the output range because you don't want to overwrite the previous table. You want to put it somewhere below. So let's put it right here. Okay, this is going to be our second regression. Okay, there it is. And now for the third one, data analysis, regression, same A column. Here, however, we need to select both of these as our X variables, okay? Again, don't forget to change the output range, put it somewhere, let's say here, a bit lower. And here's our third regression. So let's zoom out and see what we have. You have your first regression here, you have your second regression here, and you have your third regression here. And you see they correspond to the right variables, because here the return on equity is your X variable, here it's growth that is your X variable, and here you have return on equity and growth that are your X variables. Let's go back to our problem. These were the answers: 2.33, 0.704. This is where we would have read them. Here, 3.1421 and 0.0308. This is where you would have read them. And here 1.9406040218, this is where you would have read them, okay? For the follow-ups, where do we read the adjusted R-squareds? 33.3, 19.0, 42.1. The adjusted R-squared you just read from here, 33.4%, 19.02%, and 42.07%. How do you answer this question? The best model is the one that has the top adjusted R-squared. So here clearly it's 42.1, so part C is the best model. For a question like this, same thing, you're just trying to see whether it makes sense to add a interaction term, an x1 times x2. Let's open our data. So here's our data. This is our y variable we want to explain. This is efficiency, this is total risk, this is x1 and x2. And we want to create an x1 times x2, so we just do x here. This is x1 times x2. We'll call it x3. Okay? Then we drag it down. And we can run our regression. Let's do data, analysis, regression. Again, what is our y range? It's going to be this one. It's definitely not the name of the bank that is our y range. Our y range is a variable, and it is the ROA in this case, okay? Now the x range, we're going to take column C, D, and E. And again, my output range, I like to put things somewhere away from the data right here. Okay, we have labels. We've put a confidence level at 95. We can run it. There it is. This is our output. So the intercept is 2.4. Efficiency ratio has a beta of minus 0.12. Total risk has a beta of minus 0.10. And the x3 has 0.002. We can look right away at this p-value. It's not very small, but it's smaller than 0.05, so this is significant. And here we fill in the values. What is the test statistic? That one you can just read right here, 2.1237. Okay, this is your test statistic for the test of the interaction. Why do I know that it is that test statistic? Because our test is the test for B3 or beta 3. Beta 3 is what we're testing, and so t-stat 3 is the t-stat we want.